Hello, Enriched Algebra 2 students. How are you guys doing today? Let's see here. Today we are adding fractions, but not regular fractions like these. Not regular fractions like these. Oh, no. We are adding more interesting fractions like these. All right, let's see what's going on. So let's first think about how we add these fractions. Okay, so the way we add these fractions is you need a common denominator. So the 3 and the 6 are different. So we'll multiply the top and bottom by 2. So this one remains unchanged. So one scenario is we can use the bigger number. This is one scenario. We can use the bigger number, but not always. This is one scenario. We call it case 1. Okay, so we have 4/6 plus 1/6, which is 5/6. Okay, so let's see how that looks with more interesting situation. Okay, so this is the bigger denominator. So case 1 is we can try to use this one. Let's see how that looks. Okay. We will factor the bottom. It doesn't help to factor the top, and I will explain why later. Let's try to factor the bottom. The bottom factors into x minus 8, x minus 4. The right side, I will put in parentheses for emphasis, not necessity. Okay, so this is the bigger one. Case 1, use the bigger number. So this is case 1 where we can use the bigger number. So see, this is already in common. What we need on the right side is an x minus 4. And then we will have the same denominator. Okay, now we're going to distribute this. So we will get x squared plus x plus 3 over x minus 8, x minus 4, minus 3x times x is 3x squared. 3x times negative 4 is negative 12x over x minus 8, x minus 4. Okay, now notice when we added fractions, we added just the tops. We add the numerator. The bottom stays the same when we add. Okay, so if we look at the right one, we want to add the numerators. We want to add these, and the bottoms stay the same. So if you feel like you're foiling it out, the bottoms you can, but that looks worse theoretically because we like factored form better. So it just takes extra time and doesn't help. Okay, so let's combine like terms on the top. What's x squared minus 3x squared? 1 minus 3 is negative 2. Now, what's x minus a negative 12x? So that's 1 minus the negative. That's 1 plus 12, which is 13. And then the 3 doesn't have anything to combine with. And then the bottom stays the same. And that's an odd looking answer, and I wrote it a little sloppy. But that is it. And now if we could factor the top, it would look better, but most of the time we can't, and that's true in this case. So that was case 1. Okay, let's try case 2. Okay, so here you can't use the bigger number. So then we will think, okay, what's the smallest number that both 3 and 4 go into? Well, the smallest thing they go into is just multiplied by each other. So times 4 times 3. So it's 8/12 plus 9/12, which is 17/12. So case 2 was we multiply the denominators together. Multiply the denominators together. That's case 2. So in a more interesting situation like this one, we can't use the bigger denominator. Like that one's a little bigger, we can't use it. So we'll just use both of them multiplied together. So we're going to multiply this side by x plus 3 over x plus 3, and this side by x minus 2. Okay, now we want to combine the like terms on the top, but we don't want to combine the like terms on the bottom, and it doesn't look better to FOIL out the bottom. But we want to FOIL out the top to combine like terms. So it's 2x minus 4 over x minus 2, x plus 3, plus 3x plus 9 over x minus 2, x plus 3. Okay, now 2x plus 3x is 5x, and negative 4 plus 9 is 5. And then you get x minus 2, x plus 3, and it would look better if we factored out a 5 on the top and left it like this. So this looks better, and this is okay on a test. So that's okay on a test, but this is better. Factored form is better. Okay, now here's case 3. Okay, case 1 was just use the bigger number. Can't do that because 4 doesn't go into 6. Case 2 is use both of them multiplied together, 24. That would work, except we don't need to use something that big. We can use 12. So multiply by 3 and by 2. So we get 3 twelfths plus 10 twelfths, which is 13 twelfths. So here we didn't use the bigger denominator, or both of them multiplied together. Case 3 was we found the smallest thing they both went into. We found the smallest number that they both went into. Okay, let's try that on this one. So we will factor the bottom into x times x minus 7. We can factor out a x. The right, we're going to factor that into x minus 7, x plus 1. Now, we have an x minus 7 in common. What we are missing on the right side is the x. This x we're missing. And then on the left side, we're missing an x plus 1. So that is our common denominator. So now, FOIL out the top, so you get 3x plus 3 over, x looks better in front, but you can write it in any order, 3x over, x looks better in front, but you can write it in any order. Okay, now 3x minus 3x cancels, and you're left with 3 over x times x plus 1 times x minus 7. Okay, those are pretty fun. Now, the last example is just something people commonly miss. Okay, there is already an x in common. So what we need to get in common is the 5 and the 4. So we can multiply both sides by 5 and both sides by 4. Somehow people like to multiply by an additional x that you don't need. Okay, I lost it. Okay, so we get 12 over 20x minus 35 over 20x. And 12 minus 35 is negative 23. Okay. And then one final thought. All right. Something I neglected to mention. See if I can explain this clearly and quickly. Okay, let's go back to problem 2. You have 2 over x plus 3 plus 3 over x minus 2. Some people say, well, there's already an x in common. Couldn't you, like, add 5 to the top and bottom here? So the negative 2 plus 5 is the 3. So can you add 5 to the top and bottom? The answer is no. You can't add something to the top and bottom. You can only multiply. So this doesn't work. You can only multiply. Okay, so good luck with that, and we'll talk to you guys soon.